You're listening to Codepunk with Bill Ahern and Michael Zuhl, a podcast about the intersection between programming, technology, and the digital lifestyle.
Hey, Michael, how you doing?
I'm doing all right, man. It's been an interesting week. It's been an interesting couple of weeks, but apparently it's been a lot more interesting for you recently, huh?
Yeah, but I know what's going on with me. What's going on with you? It made your week or two interesting.
Kids are growing. Kids are doing things that you wouldn't expect 2-year-olds to do, which is interesting. My son apparently knows that any type of card that looks like a credit card actually goes into the card reader at the store. So he actually tried to stick my my hiking permit for here in the Shenandoah National Park into the card reader as soon as, I gave it to him to keep him quiet because Heather took away something in the store that we had to actually purchase. We were in line, and I gave him the card, and he took the card and he just looked at it, and then he looked over and he saw the card reader and he started reaching for it. And I'm like, I don't think you should know that relationship just yet, but he's my little engineer. He's always interested in taking things apart and seeing how they work. And my daughter is just your typical 2-year-old daughter. She talks a lot and she does a lot of cute things so that you know she's being cute, and she manipulates you that way. And he's just kind of like, give me something to take apart and play with. And you can give him a remote, and because he likes remotes, but he knows the difference between one that actually works and one that doesn't. So if you give him a remote, if you give him one window, and he's been doing this for 6-7 months now, if you give him a remote and he starts playing with it, he notices it doesn't change the channel on the TV or anything, and he hands it back to you and he says, broke, expecting you to fix it.
Right. That's funny.
So they're sending me to leadership skills training at work so that they can officially reassign some people to me HR wise. So that's like a huge step. That's a 7-week commitment. One day a week. It's 1 day a week, but it's still a 7-week commitment. That I have to take away from work to go to it, and they give you a book and everything. So it's good to know that work has a lot of confidence in me moving forward. We've been launching a lot of good products for medical education. So
now, how different is this from, say, is it a management position or is it like sub management?
So I'm lead developer.
Right.
So it's sub management because we do have a manager of enterprise architecture, but there's a difference between saying I'm the lead developer of this project or of these people. So I'm senior, and to actually have them listed as reporting to you in Oracle or in the HR systems. So even though they technically report to me right now because they have to come to me for their work and I assign it and they're supposed to listen to me, I'm not responsible for any of their HR. After this, they're going to start reassigning, those people, and then they'll actually report to me for HR stuff. So I'll have to do their evaluations, which means, if I continue to do good over the next several years or whatever, when I do, when there are higher management positions available, maybe they'll move me over into those, or as our group continues to grow, that just means more responsibility for me, which is always a good thing.
Oh, let me ask you this. Would you want a managerial position? Because that means less code, more budget. Stuff.
Yeah, and it's kind of a hard situation because if it was up to me, I would code and code only, for forever. And I kind of like, I've gotten into some of the project management aspects of it because I've had to actually teach some of the project managers how to use TFS effectively, how the Kanban board, works on there. And so that kind of area, I'm pretty good at interfacing with stakeholders, so they appreciate having me in those meetings and dealing with those different aspects that are not just pure development. So, I got a knack for it, and I guess I should start barking up that tree a little bit. But the good thing is that by the time I ever get to that position, hopefully the kids will be a little older. They'll be a little less, needy as far as when I'm home, wanting to always sit on my lap, and I can do more coding when I'm home.
Right. Yeah.
There's the ideal thing. Yeah.
There's nothing ever stopping you from going home and doing all your projects, which, is kind of what I'll have to do since, as you mentioned, I've got a big challenge. I left my job of nearly 10 years for much what you were talking about, better opportunities, and it's front end. And I kind of, here, it's a funny thing. And, I won't get too much into it because it's not all that exciting, but I'll definitely be able to allude to it in future topics because it'll be more, I'm a front end developer now instead of a back end. And I took it because I thought the opportunities seemed more interesting to me. And really looking back on my last decade where I was, I actually, although it wasn't my choice, I spent a lot of time doing front end just because I had to. And I wanted to do more back end, but there was a requirement, a necessity to do all this front end stuff. So I realized that I could have looked for a job that would have let me dive deeper into back end development, just like, raw C# and, dealing more with databases and stuff like that. But, I could also find a job that the learning curve wouldn't be as steep if I went with what I already knew, which happens to be front end.
Right.
So, so big transition, but it's great.
It sounds like you're going to have a lot of fun there. Well, I mean, I know you've done a lot of front end stuff. I'm sure you have plenty of time, and it'd be a little bit of a stress relief to get into a new environment and deal with a few new people. And you're still in Philadelphia with this, right?
Staying in Philadelphia. I'm actually now, their office is in the Comcast Center, which is the headquarters of the world for Comcast, although I don't work for Comcast. No, but there was
is that the one with the food courts in the basement?
Yeah. It's got a food court in the basement, and there's actually another, like a restaurant somewhere in the middle. It's like a 56-story building, I think. And there's some fancier food court somewhere. I got to find it now that I have access.
Right, because I remember we've gone to the mall over there before, which has the food court in the upper level, and then there were a couple of times where we've gone to that Comcast building where when you walk in, the walls in the reception area are television screens, and then downstairs is where there's a lot of restaurants and a salad works where people wait 50 deep just for a $10 salad, things like that.
Yeah, it wasn't bad actually. And the salads are $10, but they have a great sushi bar down there. And I think it's much bigger than we even realized, because I think it goes all the way across, like underground, under the main street. It's cool. It's vast. It's a mega corporate structure. It's pretty neat. And I like working there. And yeah, they do. You walk into the lobby, and the massive, like 100-foot wall is a giant 4K screen, like a series of 4K put together. And they always have like animations. It's really neat. I love working there, and the opportunity's gonna be great. So it's nice. Always happy to expand my, I guess my pool of experience.
So we have a pretty good couple good things going on. I mean, last podcast came out fantastic in my opinion. We've slowly and incrementally been trying to improve the audio, and I think we finally hit it. In reviewing the episode a couple of times, I think it came off great. So anybody listening to this now, you're going to obviously continue to hear much better audio than the first couple of episodes because we finally got our crap together. Yeah. The other thing that we're doing is we're finally going to start collecting some statistics on the actual downloads. I mean, I added the link in there for the statistics a couple of weeks ago, but it was well after we had launched the last episode, so we couldn't really get an accurate reading. The only thing you get is a couple of stragglers who downloaded it off of the web. So that'll be interesting to see how many listeners we have on a regular basis. The minor amount that we saw on that particular weekend that I first installed the tracking were extremely encouraging. The other good news is the website itself in the last 30 days doubled its page views from the previous 30 days. And when we went and took a look at it to see what was going on, apparently 52% of all traffic was landing on a post that I had written about encrypting your emails in Outlook 2016. So there's been a huge upswing in people, I guess, searching that topic. And I wrote that blog specifically because when I decided to do it, there wasn't a lot of information out there. I had to actually pull a bunch of different components together. So I wrote it up kind of as a quick how-to because I know I experienced issues in finding information that I needed. And so 52% of our traffic actually came from there, which is pretty cool. And I think finally, I mean, we're on like, if you search for like Outlook 2016, encrypting emails or encrypting PGP, I think we land on the first page in Google.
Oh wow!
So you can tell why we get a lot of traffic when somebody searches that. If you normally check the top 10 results of something, you're certainly going to land on our page, which that's pretty great. And then later this month, so we're in October. We're recording this on October 6th. And later this month, I will be at the EdUI conference, which is in Charlottesville, Virginia. It's a 3-day conference about higher education and usability, user interface, and they do have some coding presentations. And I'll be giving a presentation there along with one of my coworkers about TypeScript primarily. So
very cool.
That's encouraging. So anybody who has like $500 to spare, I think is what the cost is for the 3-day event, and you feel like coming down to Virginia, and there's Amtrak station goes right by there, come and visit. I think we'll be our presentation is on Monday from, I want to say 4:30 to 5:15, and then afterwards it's right on the downtown mall down there. So right afterwards we're going to hit one of the bars, have a couple of craft beers and hang out with a couple of people, so it'll be fun.
Nice. Speaking of craft beers, tonight's delectable that I'm drinking is one of my favorite, and actually I've decided that it beats out, now, of course, my all-time favorite being Founder's Breakfast Stout, and we are entering into that time of year, so I'm very eager.
That is a fantastic beer.
Really is. I really like left-hand milk, nitro milk stout.
Nitro milk stout,
It's good, but Dragon's Milk, and I've had it plenty of times. This is not the first time I've had it, but I was doing a taste test with my wife, and she's right. Actually, Dragon's Milk, which I think is a bourbon barrel stout, is probably one of the best. Now, I will say this, and we haven't gotten, I would assume that we're waiting for the fall season for all the stouts and the heavier malt beers to come out. Founders has long been my favorite, but I'm telling you, I think there's a contender for the number one spot. It is Firestone Walker Velvet Merkin. Now, that's Merkin with a K, because they also have a Merlin, like the wizard. That's not it. It's Velvet Merkin. And it is...
Any stout with velvet in the name sounds like it's going to be smooth and rather tasty.
It blew me away. Just one night we stopped off at there's a bar, just in Center City somewhere. My wife and I were just sitting down, just felt like kind of getting a beer, cooling our heels, having a conversation. And I ordered a stout. I'm like, oh, bourbon barrel stout. That sounds great. I was like, whoa. So I'm waiting for it. Just put that on your list, man. Definitely try Firestone Walker's Velvet Merkin, dude. Really good.
I actually just had, and it's probably local to Virginia. I don't know if it gets that far out in Pennsylvania, but it was a Hardywood Virginia Blackberry, and it's towards the end of the harvest season, so it came out rather late this year. And it's a nice little ale mixed with locally sourced blackberries.
Oh man,
it's not a sweet beer, but it has a nice little taste to it. It's low alcohol percentage, but you can drink the whole. It's a long format bottle. You can drink the whole thing in relatively short order, and it's pretty tasty. And then one of my recent favorites is actually from Southern Tier. It's a sour cherry ghost. So it's a tart beer. And because it's a sour cherry and it's got a little bit of a pepperiness to it, it's not overly sweet. And it comes in a 4-pack, and they're 7% alcohol, 7 or 8. I think it's 8% alcohol a piece. So
not bad.
And they're pretty good, and it's tasty. And this summer I drank a whole lot of sours. That seemed to be my go-to beer on a hot summer day. So that was those ones are some of the tasty ones that I've had recently. But yeah, looking forward to fall, looking forward to some of the better pumpkin beers rather than ones that are just taking advantage of the pumpkin flavor, and of course moving into winter with some nice porters and some nice stouts.
Yeah, man. And speaking of Southern Tier, they make probably my favorite pumpkin beer, which is the Pumpkin. I think that's probably the best one. It has the most flavor.
Right. I have one on the shelf right now for this weekend to drink it. So you've tuned into the beer tasting podcast, and you thought you were going to hear about technology. So I guess we'll get on topic. And, and Bill, how many Bitcoins do you own? Do you own any Bitcoins?
I don't own any Bitcoins. Despite our last show, I do have an interest in it, and I was looking for apps for my phone because I know Android and iPhone have a lot of apps for Bitcoin wallets. I don't know if they have necessarily Bitcoin miners on there. That would be kind of, I don't know, maybe ridiculous, but again, anything can happen. I don't. How many do you own?
Not a whole lot. I do have a Bitcoin wallet with Frack, because I think one Bitcoin is worth about $600 and something right now, 613 give or take. So clearly I don't have one Bitcoin, fractions of a Bitcoin. So you can get them in secondary and tertiary increments. One of the lowest denominator, I think, is called a Satoshi, based on a guy who did who actually wrote the specification, or the pseudonym of the person or persons who wrote the specification for Bitcoin.
Yeah, right. He's like anonymous. He's just like a name. He's not really a person.
right? And so, I mean, Bitcoins, for those, I mean, if you're listening to this podcast, you know what a Bitcoin is, but for completeness sake, we know that it's a cryptocurrency, and it's referred to as a cryptocurrency because it deals with cryptography. Virtual currencies have always been kind of a shady dealing because easily manipulated, easy to do double spending. And then once you get into a cryptocurrency, which actually uses cryptographic means to ensure transactions and ensure the validity of transactions, it becomes a little easier to combat against double spending. And so what you hear a lot on the news, you read a lot of articles, and it talks a lot about, how great Bitcoin is. It's, the wave of the future, what it means to be a decentralized currency. It's not governed by any banking system, which is, pretty amazing. Of course, a lot of the banking systems and a lot of the governments fought against it. I think there was even a time when the United States was trying to figure out whether or not Bitcoin could actually be used as a valid currency because, you can't mint your own currency. You're not supposed to be able to do that. Only the major institutions within your country are supposed to be able to mint their own currency.
Basically all through the Fed.
Right. So Bitcoin has persevered, and it is the number one cryptocurrency out there. And there are several other cryptocurrencies that are trying to rise up. But the interesting thing, not a lot of people realize this, everything you hear in the news is about Bitcoin this and Bitcoin that, but Bitcoin is a side effect. Bitcoin is not the revolutionary technology. It's actually the blockchain that Bitcoin is based on, or built on top of, I should say, that is the revolutionary part of the technology.
And I wanted to add something here. So much like the last show where we talked about Bitcoin, I went and I did some research, and you had provided a lot of notes, and I read the notes. And I'll tell you, either I'm slow or this is not light material. I read it.
It is not. It is not.
And while reading it and understanding what's being said, I go, okay, I can, and you've got plenty of, infographics, and I say, okay, I can see that and I can understand it because I'm a very visual person. I don't, sort of abstract concepts. I need to find some sort of context within which I can understand them. So I'm going to do what I did last show, and I'm just going to defer to somebody who knows way better than I do. And I'll just ask questions like somebody who doesn't have any clue, because I only have a minor clue, but you know what I mean? Like so this way I can kind of create the scope within some sort of context that makes it easy to understand, because it is really heady for me.
Yeah. To fully understand the blockchain and how Bitcoin works, you need an incredible amount of understanding of how cryptography works. And not all of the resources that are online explaining how the blockchain works are complete in their understanding. And when you get to the documentation that actually is a little more complete in its understanding, it is so utterly complex that it takes several reads just to get a grasp. It takes several reads just to try to come up with an analogy of what this may or may not be doing. So we'll try to take it piece by piece and try to remain in layman's terms as much as possible. But basically, the blockchain is the term given to what is essentially a distributed ledger. And by distributed, I mean it's decentralized and it's distributed, which means that anybody can have a copy of the ledger. Usually you install the Bitcoin mining software on your system, or you have a Bitcoin client on your system, which is a full client. So they have full clients, and then they have thinner clients. And the thinner client allows you to interact with the transaction system with the blockchain, but it doesn't actually store the blockchain locally. If you have a Bitcoin wallet, it more than likely has the blockchain either attached to it or a central, server. If you have a Bitcoin wallet on your phone, that Bitcoin wallet, points back to a website, to a central server that has a collection or a copy of the blockchain. So the blockchain is distributed. I think it's either a 5 or a 7 gigabyte file right now. So it's rather large, and the blockchain contains every transaction that has ever occurred in the history of that blockchain, from the Genesis block, which is the very first block, to every single block afterwards.
Now, let me get right in the middle of that there.
Sure.
So let's unpack what a block is. Now, this is how I understand it, and I'm probably going to be wrong, right? Which is good, because then you can correct me. So a block basically is a header and a body. Right? So the body contains the secret information that's being encrypted and protected. And the header has that sort of information that says like the hash. It's sort of almost publicly readable. It's the information that gets exchanged to make the handshake or the connection between the chain. Right. And then, so how close did I get?
Right. So the body of the block is essentially a collection of transactions. So I send you a Bitcoin payment. And that transaction has my information in it, my address, has the amount being exchanged, and it has your address in it. And then if for some reason there's any remainder funds, the transaction gets kind of completed for that as well. So they're linked transactions in many ways, because if somebody sent me money, my transaction or my end result transaction will show that transfer. And then when I send that same money to you, there's a linkage back and forth. So you can actually see how this is being transferred, because it's not as simple as I sent you $5 and therefore I sent you some digital information and you have that digital information. I no longer have it anymore. It's because it's kept all, decentralized and locally, it's essentially subtracting that amount from your transaction and creating a transaction listing. But essentially what you need to know is that, every payment or every usage of Bitcoins, it creates a transaction, and that transaction is sent to the closest or one of the closest blockchains. So if, I'm paying something at a store and I pay for it in Bitcoins, the closest thing that my phone connects to for that payment, it sends the transaction into that system, and those transactions are then, distributed. And so a block is a collection of transactions. The block body is a collection of transactions put together into a single block, and that block has a header which has several different pieces of description information. It has the hash. I believe it has the Genesis block or information from the Genesis block in it. It has the nonce, or essentially an incremental value inside of it, and what happens, and this is where part of it gets confusing, right? So we'll back up and we'll say a block is a collection of transactions. So individual people then, compete to complete that block. Those people competing to complete that block are the miners. When that block is completed, it's sent out to everybody, and it propagates across the network because it's distributed. And that block gets attached to the blockchain. It's the newest record in the blockchain, and the person who completed that block gets money for it. They get their Bitcoins that they mine. And that's what completes each block. And what happens is, all of this is encrypted and it's all based. So this is a nearly impenetrable or an unalterable system, right? So because it's decentralized, because the blockchain contains every single transaction, usually it takes, one block to complete. A second block, when it gets added, considers that, okay, you've been verified. And it usually takes about 6 blocks. And once there's 6 blocks total that have been created, your block, if it was the one that was, 6 previous or whatever, that one's considered impenetrable, because in order for you to alter the transactions within that block, you have to alter all of the blocks that came after it as well. And it's just nearly impossible to do. So it's almost, and there is an actual way to beat the system, but we won't discuss that. Well, we'll discuss it later. We won't discuss it at the moment, right? So you have your blockchain, which is your list of transactions. The blockchain contains a bunch of different blocks. These blocks were completed by miners, and within the blocks are all of the transactions. So you're able to tell, this payment address sent money to this payment address. Therefore, that payment address no longer has those funds, but the new payment address actually does have those funds.
And so that, by the way, so that history of transactions is what, like almost validation? Like it's like the validity of the blockchain, like this one particular block. Like here's the record of history saying like this whole thing is valid.
And because it's decentralized, it's valid across many, 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 many computers. And any block that's subsequently added after that, you could have more and more confidence that your completed transaction is final and it cannot be tampered with. And the beauty of this system is that you're not relying on a centralized system or a centralized banking system to manage these transactions. So it's not like I make a credit card payment, it dials all the way home to Capital One or Chase or whatever, and the transaction is logged there, and then information is sent back, and then that transaction is only kept on a server in Chase or in Capital One, and then backups are run off of it. These transactions are apparent everywhere, and they're much safer than a lot of the banking transactions as far as people being able to steal funds or manipulate funds. So the tricky part in all of this is understanding Bitcoin mining, right?
Yeah,
So
that's where I get lost for sure.
Right. So what's Bitcoin mining? So you have software installed on your computer, and the software does what is called mining in order to complete a block, and you're competing with other people in order to complete that block because you want the incentive, and the incentive is Bitcoins. I think it started out with 50 Bitcoins per successful block, and then it gets halved every 21,000. I forget the exact number, but it gets halved at an incremental value, and eventually it will get halved to the point that you will no longer get Bitcoins when you mine. So there's a set number of Bitcoins that will only ever be produced.
Okay, now do you understand why that is? Like what is the algorithmic imperative for that?
I don't know if there's an algorithmic imperative for stopping the production of Bitcoins, but they didn't want to, I'm assuming that they didn't want to make it so that you could just continuously print money. So it's essentially a deflationary currency, which is fine because even though there is a set number, it's virtual currency. And as the value of Bitcoins go up because they become rarer and rarer, there are exchange markets where you can exchange Bitcoins for money. So, and like I said earlier, the Bitcoins can actually be broken down into smaller units. So even though there might be a set number of them, you still have the ability to purchase a share of a Bitcoin or a share of a Satoshi or whatever that has a value in US dollars or in yen or in whatever other currency,
right? Whatever currency
euros.
exchange it would be. Now, here's a question: what's to stop someone from starting their own version of a Bitcoin using blockchain the same way, but basically resetting the whole ability to acquire some new form of cryptocurrency?
So they kind of have that. So there's the Ethereum blockchain essentially, which is a different type of cryptocurrency, and their blockchain essentially allows you to run distributed contracts within it. So there's a whole bunch of different ways to run distributed applications or distributed ledgers and distributed contracts. So there are other cryptocurrencies out there that are attempting to duplicate what Bitcoin has been able to do, but aren't as hard on, we're only going to produce, Bitcoins or cryptocurrency up to a certain point. And I think Ethereum right now is trading at about $12 or $16. So one Ethereum is worth about 12 or 16 US dollars. Now the thing about Ethereum was that they had a large scale attack recently where I think somebody had stolen a significant amount of Ethereum and they didn't know what to do about it. And so what they ended up doing was they actually rolled back the blockchain to the point before the attack occurred, before the hack occurred, and the money was stolen. And by doing so, it's caused a bit of a rift in the cryptocurrency community. You actually have people who are still running with regular Ethereum, but then there's another, it's been forked. So there's essentially another branch that's the Ethereum Classic, which includes those transactions because they wanted to be pure with the blockchain and not just say, well, you have the authority to roll this back and essentially wipe out the transactions that occurred simply because somebody stole a bunch of money.
Which has to be a concern, right? Because my feeling is, let's say I invest in something, I don't want some sort of governing, whoever made that decision, right? Means they have some ability, some power to roll back and wipe out some series of transactions. Again, as we've established, a form of authority or validation of that block, in that blockchain. If people can arbitrarily roll it back, that seems like a little bit. Well, again, it almost makes it feel arbitrary. And I know that
Right.
was certain skepticism that cryptocurrency meant in the beginning is like, where is the real value? Obviously, American currency has oil and used to have gold backing it as a way to kind of, subsidize it. What subsidizes the value of these cryptocurrencies? Especially if people could just wipe it out at will.
Right. So I want to say Coinbase is a Bitcoin wallet that uses so it's stored, it's cryptographically signed and stored on their servers, and according to their documentation, they actually store a hard value of it off-site, like in a safe. So essentially they take whatever your code is for that particular transaction of money, and it's not necessarily on a centralized server where somebody could hack in and steal that. So there are companies who are making a concerted effort to protect your Bitcoins or protect your cryptocurrency from hacks like that as if it was real paper money, which I think is pretty good. I mean, Bitcoin, like I said, they have a set amount. They certainly have a ledger that is almost impenetrable. The only way, so a 51% attack is the only thing that people worry about when it comes to cryptocurrencies or something like Bitcoin. So a 51% attack is when a person or a group of people have enough computing power to essentially complete 51% of the blocks in a particular ledger, in a particular blockchain. So they could essentially take control of the network, and then if you own that much of the network through the completion of blocks, you can essentially alter the blocks. But that hasn't been the case, and it's so basically, to get back to the whole point of Bitcoin mining, I mean, you mentioned perhaps a Bitcoin miner on your phone, which would be nearly impossible because the CPU or the GPU or the available resources on your phone are just not good enough in today's cryptocurrency market to have the computational power to complete the necessary blocks in order to compete with everybody else. So here's essentially what happens, and some of this is beyond my immediate understanding, but I've done my best to research this and try to relay this information to you. So there are two things at work. One is difficulty level, and one is solving of an algorithm, essentially. So when we mentioned the blockchain, the header of the block, when we mentioned the header of the block recently, that's actually what gets hashed, right? And that gets hashed with a doubled version of SHA-256. So you have the information in the header block, and then you essentially have an incremental value. And you're looking to, and so O'Reilly has O'Reilly has 3 books. They have Mastering Bitcoin, they have Blockchain, and they have Decentralized Apps. Only one of them is essentially worth anything, and that's Mastering Bitcoin, which has had fantastic reviews, and there's a ton of information in there for how to understand how this actually works. And the way he explained it, which makes a lot of sense, is that essentially you are given a puzzle to solve. And you continuously hash the header with varying increment of nonce until you meet the requirements of that puzzle, till you solve that puzzle. And once that puzzle is solved, it then goes out to all of these other people who then verify the puzzle. And when you look at a puzzle, it's easier to see that it is solved because it's been solved. You can look at it and you can verify it much faster than if you try to solve it yourself without actually knowing what you were doing. So that's why verification is so fast, but solving the algorithm isn't. So you need to, as an individual, basically take the header of this block and figure out through an algorithmic formula, just simple hashing and consistent hashing. And there's randomized information in there. So essentially it contains all of the transactions you have up to that point, plus an interval, plus a difficulty, and all of these things kind of together. And changing any one of those values will essentially change the output of your hash. But you're essentially looking to solve for that by continuously hashing with the incremental value and changing that incremental value until you meet it. Once you meet it, you get your payout. And then you move on to the next block. If somebody else completes that block that you were working on, when you get your information back, all of the transactions that have been included in that block that somebody else solved get stripped out of your block that you're trying to solve. You add more transactions to it, and you continuously try to hash it, and so forth and so on. So that's essentially how Bitcoin mining works. The secondary part to that is the difficulty level. So Bitcoin is set up so that it essentially solves a block every 10 minutes. So if a block is solved every 10 minutes with 10 people mining and then 1,000 people start mining, obviously you're going to complete those blocks a lot quicker. So the difficulty level of the algorithm of the hashing actually increases in order to maintain that 10-minute window. So as more and more people have been mining for Bitcoins, the difficulty level has gotten higher and higher, which requires more and more computational power in order to solve these algorithms, which has essentially made it impossible for somebody like you or me to sit down with our computer, install a Bitcoin mining client, and actually mine close to anything. That's why they now have specialized hardware that you can buy and plug into a system in order to try to mine for Bitcoins. And then a lot of people nowadays actually join Bitcoin mining pools in which you're a part of a group and you're essentially mining together. You're pooling your computational resources in order to mine together. And then if you complete a block, you get a fraction of the Bitcoin payout.
Yeah, I've seen that. I've seen that actually. I think Amazon sells Bitcoin mining hardware. It's just like a black box that you plug in, and
right.
Which is, I thought was kind of funny, but I didn't realize it sounds weird. It almost sounds like some form of SETI at home. And for people who don't know what SETI at home is there's a lot of data that has to be crunched from, who is it? It's not NASA, is it? Just SETI, the search for
SETI, the institute, right?
SETI Institute, the search for extraterrestrial intelligence. There's a lot of data that they collect from, pinging outer space. I mean, I can't speak with a lot of authority on it, but I know that there's a lot of data being collected by scientists about, sending signals out and trying to gather information they're getting from outer space, and they crunch that. And SETI at home used to be a thing where you could put a little thing on your computer and it would use up any sort of unused processing cycles from your CPU. If you're sleeping or whatever, it's just not using your computer, it basically would create a distributed network of CPUs to help crunch all this data. And that's what it sounds like, except with SETI at home, there's a goal. Other than just solving a puzzle, what's the goal with Bitcoin and the blockchain? Like, that's the thing I had never really understood. Like, to what end is all of this number crunching?
So the incentive is the money, obviously. You do get Bitcoins for solving it. And eventually you won't get Bitcoins for solving it because, they'll stop making Bitcoins. But one thing that actually does happen is just like any merchant account or just like any bank or any other machine, there's a transaction fee involved. So if I send you, we'll say $10 worth of Bitcoins, it might be that the transaction actually cost, $10 worth of Bitcoins and a small fraction. So there's a minimal transaction fee involved in any transaction that occurs if I send money to you or you send money to anybody else. And the people who actually do the mining, if you are one of the people who solves the blocks, you don't just get the payout from solving the block that Bitcoin is delivering to you, but you also get those transaction fees. So even when there are no more Bitcoins to mine, somebody who has Bitcoin mining hardware and has that server up and running makes money off of the transactions. So you're essentially selling your services as part of this distributed network in order to improve, cryptographical currency, in order to improve transactions in a decentralized manner. So you might get to a point where you just plug a device into your wall and you act, as the altruistic person that you are. This is my Bitcoin miner. And this is so that, just as this, we spoke last episode about Tor and Tor networks and how you can be set up as a Tor node. What's the incentive of that? Well, the incentive is that you're helping privacy. The incentive in this is that you are promoting distributed transactional systems, for a ledger, which is much better than the centralized systems that we have today.
Yeah, because, that was one of the other things too. Like, I understand that people who are going to mine Bitcoins want to get that Bitcoin money, but it's just, the funny thing is I try to imagine, like, Satori or whatever the name of the guy or whatever, the shadow brokers who came up with this, like sitting around trying to figure out a way to come up with a cryptocurrency using blockchain going, let's make it a game. And whoever crunches the most numbers or, like, you're going to get the prize. It's weird. Like, I can't get my head around the sitting down and trying to put together a system like this baffles me. It just isn't. I guess it's just not really the way I think or the way I would come up with technology. But then again, this stuff is clearly for brilliant people, not me. Because that's what it feels. It sounds like a game. It sounds like a game to see who can crunch the most wins.
What is the gamification of, virtually anything? And we spoke about that in a previous episode about how a lot of things on the internet are gamified. The value in it is in the decentralization. It's more than just banking, when we talk about it. Sure, you have the ability to send, monetary transactions, and that was part of the reason for the construction of this. But they, and believe me, centralized banks today are actually looking into using blockchain technology. So they're not going to be, okay with, Bitcoin just running around doing its thing. They want to find a way to take advantage of the technology and try to own the technology. And it's funny because, and it's timely because I just finished wrapping up season 2 of Mr. Robot, and Bitcoin plays a small role in that. But the main evil corp, the main bad guy institution in there is trying to roll out their own version of a cryptocurrency in order to combat the economic woes that are occurring in the series. So it's kind of, you're seeing the same thing today. You're seeing banking institutions trying to own this idea of cryptocurrency because they want to get out ahead of that. And the wealthy want to remain wealthy, and they want to find some way to keep it at least somewhat centralized between banking institutions and not decentralized amongst all of the other individuals. But think of the other applications you could potentially have. Like I said, it's not just about decentralized, transactions for currency, but you're talking about distributed systems. Stuff like SETI. It's not just about distributed systems, but it's about distributed systems whose records get stored in a way that is nearly impossible to alter. The security mechanism, the cryptography surrounding it is what makes it so valuable. And I can see at some point in the future, we always talk about why is there not any online voting and how easy it would be, if somebody started to do online voting, how easy it might be for it to get hacked and for those records to be altered. But you could almost see an application of the blockchain towards, online voting.
Right.
I'm
glad you brought that up because, as I was reading through some of the documentation, they talked about Bitcoin, but they also talked about, as you just mentioned, think about a way of completely impenetrable, secure data exchange in a way that isn't necessarily coming from a single source. So it can't be compromised or shut down. And I started wondering, well, what would be an example of a good application? And you nailed it. Online voting would be perfect.
Yeah. That was like the first thing that kind of came to my head as far as, a realistic application of this technology that's outside of money. Can we do online voting in such a way? And to take it a step further, if we're talking U.S. elections, there has to be some sort of verification that you are in fact able to vote, and you don't want to cheat the system by being anonymous in some way. But so you have the potential application in U.S. voting, but then you also have this application of I don't want to say distributed societies, but distributed groups in which information can be transferred anonymously and securely, through the ledgering system. And imagine the Middle East. Imagine another Arab Spring, and instead of using Twitter, which can be blocked, or instead of using Facebook, or instead of using any type of the social media that was initially used during the Arab Spring. And there were attempts to obviously suppress it by, the regimes that were out there. Imagine now, in order for these rebels, or in order for these, revolutionaries to communicate, they're using a cryptographically signed distributed system, and there's no central server that can be taken down in order to eliminate it. There's no tampering that can actually be done, to eliminate some of those transactions or eliminate some of those messages or take away, important information that has been leaked. You're talking about a rather important utility, for revolution if you have a distributed informational channel that masks its users but keeps that information, intact within the blockchain.
Right. Imagine again, like a dark net using a Tor that is using blockchain, right?
Right.
Again, it's the present. Yeah. Because if you treat information like currency, which obviously the metaphor has been there forever, the value of it and the power of it and the ability to invoke change. That's a very powerful thing.
Imagine me, instead of transferring Bitcoins to you to pay for a cup of coffee, I'm transferring to you vital information. And because it's cryptographically signed, you can receive it and only you can receive it. But at the same time, because it's part of the blockchain, if for some reason your phone gets taken from you or intercepted, or the computer that you were using gets intercepted, you could obtain that blockchain anywhere else at any point with any piece of equipment that you have and still be, the information is always there and it's always within a system. You would have to bring down every single, point of that blockchain in order to eliminate that information. For things like, government leaks of information. I mean, that's a place to embed. In fact, the blockchain has a lot of embedded crap in it that actually isn't transactional information. People have embedded poems and other things within the blockchain, which isn't necessarily a good thing, but it shows that you can put virtually anything in there and it lives on forever.
Right.
There's probably porn in there somewhere, you know?
There's no doubt. But that's the thing. So again, going through the documentation and reading about it and talking about the ability, the amount of applications that go beyond just currency, just money, it kind of talked about, well, you were saying earlier that we thought maybe, this thing, you can't create money because the governments and, the Federal Reserve are going to kind of quash that, but it's persisted. And in that persistence, I think the value of it is so obvious. And as we've illustrated, beyond just money and purchasing, that, well, basically, I think it's the O'Reilly book that you mentioned talked about its ability to disrupt, and that the disruption that comes from blockchain technology is almost inevitable. Do you agree with that?
Absolutely. Absolutely. And it was when I first heard of Bitcoin, I only knew, Bitcoin, cryptocurrency. I didn't initially see a value in it. And then obviously with Tor and with the darknet, clearly there's value, in using that because it's not tied to you individually. It's just, this code that has money associated with it, but it's still cryptocurrency, it's fluctuating in prices up and down. Anything could happen. Mt. Gox or whatever went out of business and stole a bunch of people's money. There's all kinds of ways that it's not necessarily, it's volatile because it is a volatile market. But then when I started to investigate more and more of what actually is this, and then I started to read about the blockchain, and I was like, whoa, wait a minute, we all missed the boat. We've been focusing so intently on Bitcoin as a currency. Most people didn't realize, especially, people who aren't, computer scientists or engineers, that the value and the revolutionary, piece of technology within this whole thing is actually the blockchain and how it's able to do distributed ledgers, and it opens up a world of possibilities with distributed systems. It's just a fantastic piece of technology that a lot of people don't understand, so it hasn't been fully realized yet, and people are still trying to figure out new and interesting ways to utilize it in order to create better systems. I mean, we came up with the obvious one of voting, but there's all kinds of other things that could probably be done with it. We've just scratched the surface of what's going to be capable of, and how it's going to change a lot of interactions and a lot of transactions and a lot of systems, over the coming, decades.
That's it for this episode of Codepunk. You can subscribe to this podcast on Google Play, iTunes, and Stitcher, or listen to it on the web at codepunk.io. You can find Bill on Twitter at Norathustra and Michael on Twitter at Zool.